Hello everyone, welcome to my talk. I'm Aksha Nikom, graduate student at Center for Atmospheric and Oceanic Sciences, Indian Institute of Science, Bangalore. Today I will talk about under what conditions monsoon low pressure systems give extreme rainfall events of different spatial extent. So when we say extreme rainfall event, they are of different spatial temporal scale. Here I have shown four examples. So in top panel, you can see two examples of small event, which were localized event mostly. On the other hand, bottom panel shows widespread event. So event like this uh, occupied almost an entire state. So how similar or different these events are that we will explore in this talk. So to study this, we consider Central India as a study region shown here in dotted blocks. We use IMD graded data set and to identify the spatial extent or size of event, we use algorithm called connected component algorithm. Here, size of an event is number of grids occupied by it. So once we get events with different sizes, we classify them as small, medium, or large. Small events are the one which are isolated, which occupy just one tree. Medium have size 2 to 5, and greater than size 6 are large event. So this particular event is example of large event. Previous studies have shown events over central India are mainly associated with monsoon low pressure system. So we check this using early and boost data set. So here I have shown example of monsoon low pressure track, and shading here represents rainfall. So this is an extreme rainfall event. Uh, so this data is available from 1979 to 2012. So that is our study period. And in our analysis, we use era interim data set for meteorological variables. So for central India, what are typical sizes of event that is shown over here? So x-axis is size of extreme rainfall event. Here bar represent the probability of getting different sizes of event. We can see small events are most probable event. And here purple triangle shows how many of such events were associated with monsoon low pressure system. So more than 80% of all events were associated with monsoon lows, and all of large events were associated with monsoon lows. So bottom panel shows rainfall distribution for these three different classes. We can see large events are not only bigger in size, but they are intense as well. So in this study, we consider only those extreme rainfall which were associated with monsoon lows. And this is spatial distribution of these three types of extreme rainfall with respect to monsoon low. So center of this plot is location of low pressure system. We can see large events occur very close to low pressure system. Small and medium, they can occur slightly far, but mainly in the western sector of monsoon lows. What are the characteristics of LPS when they give extreme rainfall of different events, like small, medium, or large? So we classify them into these three classes, and we have one more class of LPS, LPS NOx, which considers LPS that pass through central India and do not give any extreme rainfall. So here I have shown CDF, cumulative distribution function, for different properties such as relative vorticity at 850 HPM, speed of propagation of low pressure system, and total column water vapor. So here we can say LPS that did not lead any extreme rainfall were significantly weaker, faster, and drier than LPS that produced extreme rainfall. Among these three classes, uh, they have different strength. Strength is significantly different. So significance test we do using KS test for CDFs. The speed of propagation is not much different, and even water vapor is not much different. Then we check different characteristics of such event. Mainly two categories we consider: thermodynamic characteristics, which are associated with temperature and moisture, and dynamic characteristics, which are associated with circulation. So top panel here shows distribution of vertical velocity, or omega, at 500 HPA with respect to location of extreme rainfall event. So here we can see the maxima of pressure velocity matches with the location of extreme rainfall, and even spatial extent of this maxima roughly matches with the maximum rainfall. So here we can say, and this omega is significantly different for small, medium, and large. On the other hand, bottom panel shows another thermodynamic characteristics, which is relative humidity. So with respect to height, here we can see the spatial extent of RH or maximum RH is not coincident with the spatial extent of extreme rainfall. However, for medium and large event, there is deep saturated air which is not present for small event. So likewise, we check other characteristics. This is low level equivalent potential temperature, which is not much different for this three event. On the other hand, omega is different. So in nutshell, what we find that generally thermodynamic characteristics of LPS that gives three different sizes of extreme rainfall are similar. However, they have different dynamic characteristics. Uh, what are the background conditions under which low pressure system gives these different classes of extreme rainfall? To explore that, we first check the spatial distribution of extreme rainfall for these three classes. So here, this plot shows the count of small size extreme rainfall event. Here we can see they occur maximum over Western Ghat and northern part of central India. On the other hand, medium and large event, they occur mainly over central India. So there is a study by Goswami et al., which has looked at the path of low pressure system during different intraseasonal oscillation phases of monsoon. So monsoon has two phases of intraseasonal oscillation. One is called break phase. So during break phase, the rainfall over central India is below than normal, and monsoon trough shifts northward near foothills, and subsequently monsoon lows follow that path. On the other hand, during active phase, monsoon trough is present over central India, rainfall is above normal, and monsoon lows pass through central India. Here we can see resemblance of path of monsoon track and medium and large event. And for LPS of break, we can see the location of small is slightly northward. So is there any connection between the phases of monsoon intraseasonal oscillation and extreme rainfall of different spatial extents? So we speculated that and it turned out true. So here we have shown background condition using geopotential height at 500 HPL for small, medium and large event from day -2 to day 0. So day 0 is day of extreme rainfall. Here we can see for medium and large event, there is active monsoon trough, which is not present for small event. Rather, for small event, anomalies are more over southeastern India, which is typical feature of break phase. So here we can see for a large event, there is additional synoptic system, which is called secondary cyclonic vortex, that we studied in our earlier paper. You can check this one for more details. So in nutshell, the medium and large event had a presence of active monsoon trough, but for small event, it was not there. And even for LPS, which did not lead extreme rainfall, it was a case. Using different parameters like mean rainfall over central India or meso index, we further confirm that it is true that medium and large event occur during positive phase of meso, and during neutral or negative phase, we get small events or LPS which did not lead any extreme rainfall. So how does positive phase of meso helps in large scale extreme rainfall event? So that can be checked using various processes. So this plot shows dynamic forcing, which is modified Q vector over central India. And here, so it is time series from day -2 to day +10, where day 0 is day of extreme rainfall. So here we can see for large and medium event, there was dynamic forcing present, large scale dynamic forcing present over central India, which was not the case for LPSSM and LPS no EX. indicating that there was no large-scale forcing. So this large-scale forcing is present because of trough associated relative vorticity and positive temperature anomalies. Likewise, we saw that there is intensification of monsoon lows when they pass through positive phase of meso, and there is diabatic generation of potential vorticity. Due to time restriction, I'm not including those processes, but you can check more details in our preprint here. So this is summary of talk. We checked four classes of LPS. One with LPS that passed through central India and did not give extreme rainfall event, and three classes with different spatial extent. So LPS that did not lead any extreme rainfall event were significantly faster, weaker, and drier than LPS that produce extreme rainfall. Among the classes of LPS that led to extreme rainfall of different spatial extent, thermodynamic characteristics were similar. However, dynamic characteristics were different. Then we checked background condition. We found that the LPS which led to medium and large event, they occurred mainly during positive phase of meso. On the other hand, LPS that did not produce extreme rainfall, or the one which produced small events, occurred mainly during neutral or negative phases of meso. And there are various physical processes that can explain why LPS of positive phase give large scale extreme rainfall event because of large scale dynamic forcing, intensification of LPS that can be shown using vorticity budget, and diabatic generation of potential vorticity strengthens low level circulation that can help in organization of convection and gives large scale extreme rainfall event. So thank you for your attention.